little bit about myself. My name is Andrew Pruski. I'm a SQL Server DBA, Microsoft Data Platform MVP, and I'm a certified Kubernetes administrator. Originally from Swansea, Wales, but I've been living in Dublin, Ireland for coming up to 8 years now. If you want to get in contact with me after today, if you have any questions, please feel free to reach out. I'm always willing to talk about this stuff. So my Twitter handle's there at DBA from the cold, and my email address is there as well, dbafromthecold@gmail.com. My blog's there as well, dbafromthecold.com, posted multiple articles about running SQL Server in containers, some of which I'm using to base this session on, and some of which go into even deeper details. So if you want to check that out, you're more than welcome. And then finally, at the bottom there is my GitHub account. All the code and the slides for this session today will be up there even, and I'll post the exact link at the end of the session. So on to the session. The aim of this session is to dive deeper into the Docker platform. I'm assuming most people here have spun SQL Server up in a Docker container and played around with it. If you haven't, don't worry, we'll cover how to do that right at the start in the demos. But what we're going to do here is we're going to go deeper into the platform and have a look at a few specific things. Those things being container isolation. How does isolation in a container actually work? Then we're going to have a look at networking. We're going to spin containers up on the default network that we usually do when we spin containers up. And then we're going to have a look at building custom networks that we can attach our containers to. Then probably the most important topic for all of us SQL Server folks, and that is persisting our data. How do we persist data from one container to another? And we're going to have a look at a couple of methods of doing that. Then we're going to have a look at something called custom images. We're going to use Docker files to build custom images. So we don't have to just rely on the default images that Microsoft give us. We can build our own. And that comes with a couple of advantages, which we'll see in the demos. And then finally, we're going to wrap everything that we've been talking about together and use it in something called Docker Compose. But first things first, container isolation. Now, when we talk about containers, you get a definition like containers are an isolated environment that contains all the necessary binaries and libraries required by a piece of software so that it can run in the same manner regardless of its environment. But it kind of brushes over isolation, just says, oh, it's an isolated environment. How do containers actually get isolated from the host? Because there isn't actually such a thing as a container. Containers are just processes running on a host. And there's a few constructs that are implemented to provide that isolation. The first one being control groups or C groups. Control groups control the resources that a container uses on the host. So by implementing control groups, we can limit things like CPU and memory available to individual processes or containers. So that's control groups, controlling the resources of the host. Then we have namespaces. If control groups control what a container can use, namespaces control what a container can see. And they're used to do things like change the host name within the container. A container sees a different host name than the actual host that it's running on. It controls the processes that a container can see. A container typically can only see its own processes, not all the processes running on the host. That's because it is in a namespace. And the last one there, mapping users in the container to users on the host. This is the user namespace, sorry. The user namespace allows for processes in a container to run as a user that is mapped to a different user on the host. Now, by default, Docker doesn't implement this, and that can cause issues, and we'll have a look at that in the demos. So we've got control groups, controlling what the container can use, namespaces, controlling what the container can see. But there's one more construct, which is the file system. Containers cannot see the entire host file system. They only see a subset of that file system. They think they're at root on the host, but they're not. They're at root somewhere. Their root is changed upon startup, so that the container can only see from that location down. It can't see out of that little location. It's got a subset of the container host. So by using control groups, namespaces, and changing the root of the container, this is how container isolation is achieved. And let's go and have a look at that in a demo. So I'm in VS Studio Code here, and I've got up on my Docker host. So let's run a container. And we're going to limit the memory available to it. So we're going to start off with a simple Docker run statement. We're saying Docker container run -d, demonize it, run it in the background, detach it. so I can continue using this shell. Publish and ports. What I'm doing here is I'm mapping port 15789 on the host to port 1433 within the container. So what that means is anything hitting the host on 15789 will be mapped into the container on port 1433, and we can connect to SQL Server. And I'm just plucking 15789 out of thin air. I don't need any specific reason for using that port. I just need a port on the host that's not currently in use. Then I'm going to set the memory flag. I'm going to limit this container's memory to 2 gig. I'm going to accept the end user license agreement, specify an SA password so we can connect, give my container a name, and then specify the image that I'm going to run. I'm going to run the 2019 CU5 Ubuntu image. So, that container. I'm going to worry about my kernel, but that's because of the host that I'm running, although we don't need to worry about that. Okay, let's confirm that container is running. I say Docker container ls-a. By default, this only shows running containers. -a says show all containers no matter what state they're in. And there we go. We can see it's got a status of up. All good. Now, I don't particularly like that output because I've made the font size on Visual Studio Code for demo purposes a little bit bigger. I'm going to trim that so we get it a little bit nicer in the screen there. I'm going to use this format flag. And there we go. That's a little bit nicer. So pretty impractical. I only ever use it when I'm doing demos. Usually Docker container ls-a is fine. But there we go. I can see now I've got my ports, my status, my image, and my container name. And it's up. Great. Okie dokie. So let's go and have a look. Grab that container ID, and let's have a look at the control groups created. There's a whole bunch of them, but ones we're interested in are memory and CPU. So let's have a look at those. We can grab the location of the memory and CPU control groups. Grab the memory limit, it's in bytes, so divide it a couple of times, and there we go. There is our memory limit in place. When we use the -- memory flag, what's happening in the background is that container has been dropped to a control group that is actually implementing that limit. So that container is limited to 2 gig. Let's have a look at the CPU one though. If we grab that, we can see that it's -1. It is unrestricted. I didn't use a flag to cap the CPUs of that container. So -1 means it is unlimited. There's no limit to the CPU that this container can use. So let's go ahead and let's update that container. Let's limit it to 2 CPUs. I'm saying thanks, Anthony, there, because a while ago, Anthony Nocentino showed me this code. I was under the impression that you had to shut down the container, update, start it back up. But Anthony was like, oh, no. You can do it on the fly. So now we can have a look again. And there we go. It's 200,000. But that is essentially limited to 2 CPUs. So by using the -- CPUs and -- memories flags, we can limit the resources of the host available to our container. And then in the background, control groups created to implement those limits. All right, now let's have a look at the namespaces. Now we can see that there'll be a whole bunch of namespaces. One we're looking at is UTS, and we're going to have a look at PID. Now UTS stands for Unix Time Sharing System namespace. It sounds pretty scary, but all it really does is implement the ability for the container to see a different host name than the actual host. So let's have a look at that. So view the host name of my Docker host. I'm really unimaginative, so I've just called my host Docker. And then if I use docker exec, the command docker exec, I can run a command against my container. I'm going to run host name. If I do that, boom, it has a different host name. It's a container ID. And this is because it is in a UTS namespace. You can see a different host name than the actual container host. So let's have a look at the processes running within the container. So if I do ps-awk, within my container, I can see my 2 SQL Server processes and the command I've just run. Running as a SQL user, and they've got PID process IDs there. If I do that on the host, there they are again. The different PIDs. And because the MS SQL user doesn't actually exist on my host, I just get its ID number there. So that's because this container is in a process ID namespace. It can only see its own processes. It can't see all the different processes on the host. So if I grab that PID, I can actually do stuff like using nsenter to jump into the namespaces and do things like check the host name, check the processes running. So I don't have to use Docker commands to do this. I can use nsenter, another Linux command. I can jump into a namespace, have a look around, see what's going on, and then I can jump back out. So we've got control groups, controlling what the container can use. namespaces, controlling what the container can see. Let's run another container, and this is going to be run from a custom image. It's also available on GitHub, but all it does is run SQL Server as root. We saw there in the previous one that SQL is running as the MS SQL user. So if we run that as root, we can have a look at the processes on the host again. And this time, we can see SQL is running as root on my host. That's because the user namespace isn't implemented. So if SQL runs as root in the container, it will run as root on the host. Now, that could possibly give it a little bit more permissions than we want it. So that's one of the main reasons Microsoft switched from running SQL Server as root in containers to running as a custom MS SQL user. Okie dokie. So that's namespace and control. Let's have a look at changing the root of the container. If we do this, we create a database in our container. There we go. And then we list out the files. So it's var opt MS SQL data within our SQL1 container, and there's our database files with all the system databases. Okay, so in the container, it's var opt MS SQL data. If I try and list that out on the host, it doesn't exist. That's because the container's root has been changed upon startup. And I can grab that location by running this, and then we can have a look at it. There's var there. So if I do files, then var opt MS SQL data, there are the files on the host. So they're in a different location than where the container thinks they are, because that container's root has been changed upon startup. So that's the three concepts. We have control groups, controlling what the container can use, namespaces, controlling what the container can see, and changing the root of the host, of the container itself. Okay, so let's do a little bit of a cleanup here. There we go. And we'll jump back into the slides. Okay, so that's isolation. Next thing I want to talk about is container networking. If you jump onto a container host and run Docker network ls, you will see three networks there by default. Bridge, which I'll talk about in a second. Host, pretty much remove network isolation between the container and the host, use a host networking stack, and then none, which means disable the container networking stack. Really handy if you want to run a hyper isolated environment where you want an exec in, do some work, and then blow your container away when you're finished. There are a whole bunch of other stuff. I'll cover that in a second, but let's talk about the default bridge network. This is the default network. When you spin up a container, this is the network that your container runs on. And you can see it by, if you list out networks on your Docker host, you'll see it as the Docker 0 network there. The containers can communicate with each other via IP address. So any container on the default bridge network can communicate with all the other containers on that default bridge network via their IP addresses. And it supports port mapping as well. And we saw this in the first demo where I mapped port 15789 to port 1433 on the host. So that's the default bridge network. But we can create user-defined networks. And Docker provides a few drivers for this. We already saw three of them: bridge, null, host. Mac VLAN, you can assign a MAC address to your container so it looks like a physical device on the network. I've never actually done that, but you can do it. And there's overlay as well, which is used to combine multiple Docker daemons together, say in Docker Swarm. But if you just create a network without specifying a driver, you will get a user-defined bridge network. And the user-defined bridge network has some advantages over the default bridge network, chief one being that it supports DNS resolution of container names to IP addresses. Now, containers on the default bridge network can communicate via IP address, but they can't communicate via the container name. Containers on a user-defined bridge network can communicate by container name. And we'll have a look at that in the demo shortly. Containers can be connected to more than one network, and you can disconnect and reconnect to user-defined networks without having to restart your containers. To remove off the default bridge network, you have to shut the container down, remove it, start it back up. But that's enough of me talking in the slides. Let's go and have a look at a demo. Okay, so container networking. Alrighty, so if we list the networks out, you can see here we have our three defaults: bridge, host, and none. If I inspect the default bridge network, you can see I've got a whole load of information here: subnet, gateway, and containers. There's nothing there. There's no containers running. So let's run two containers on the default bridge network. So I'm just saying Docker container run, accepting the end user license agreement, giving them names, and I'm running from another custom image. This has just got a couple of tools installed, chief of one being ping, that I want to use because I want to show you these containers talking to each other. And notice I'm not mapping any ports here. So I'm going to have to connect via those containers' IP addresses. So there's a run. Let's have a look. There they are, up in 7 seconds. Absolutely fantastic. Right, now I can have a look at that network again. And this time I have 2 containers on there with their IP addresses. Okay, so what I can do is I can grab those IP addresses. And if I try and ping one container from the other via container name, it's not going to work. DNS resolution of container names to IP addresses does not work on the default bridge network. But they can communicate via IP address. So we can use those IP addresses, and we can do things like connect to SQL with them. Same as done using the MS SQL CLI. Oh, by the way, if you haven't checked out the MS SQL CLI, highly recommend you do. It's like SQL command on steroids. It gives you things like IntelliSense and stuff like that. I really like it. But okay, there we go. I can connect to SQL using that container's IP address. Now, let's get rid of those 2 containers. And say I do want to run containers on default bridge network, and I know what their IP addresses are going to be. I can do a little trick here, and I can use this add host flag, and I can write an entry into my container's host file for all the other containers that I want them to communicate with via their container name. So here I'm saying container 2 and its IP address, and down here, container 1, its IP address. Okay, so let's run that. Excellent. Okie dokie. Let's have a look at them. And now, because I've written that hostname file in, I can get my 2 containers on the default bridge network talking to each other via their container name. Okay, right. It's not great. I will admit, because you have to know the IP address of the container before you spin the other container up. But still, if you don't want to create a custom bridge network, that's an option for you. And this time, let's run 2 more containers. And this time, I'm going to use the publish flag. Pretty sure everyone's seen this when they run a container. But this time I'm just mapping a port on the host to the port within the container. So now I can view those port mappings. Oh, there we go. And I don't have to grab the IP address. I can use localhost or my host IP address and the port. Oh, and I was a little bit too quick, was I? Go on, please. There we go. All right. And I can use localhost and the port that I've mapped to port 1433 within my container. And I can use localhost or the IP address, the port number, and I can connect into SQL. And this is pretty much the standard way everyone connects to SQL running in a container. Okie dokie. So let's get rid of all those containers. Goodbye. Not looking around. Oh, hello. There we go. Right. Now let's create a custom bridge network. So I'm saying Docker network create. I'm going to call my network. I'm imaginative as always, SQL Server. Now I didn't specify a driver here. So when I list out my networks, we get a new network with a type of bridge. This is the default bridge. So I've created a user-defined bridge network. Now, let's run 2 containers on that custom network. Again, running from the custom image, just so I've got ping installed. There we go, 1 and 2. And we can ping these containers via name. Okay, there we go. So by using a user-defined bridge network, I can get my containers talking to each other via container name without having to do anything else. So I don't have to write entries into the host files or grab the IP addresses, things like that. That's because DNS resolution is supported for container name to IP address on user-defined networks. And we can view that here. If you have a look at the DNS settings for a container, that is the IP address of Docker's DNS server. Docker has an internal DNS server that user-defined bridge networks can use. Okie dokie. Right, so I'm going to do a bit of a cleanup here. Let's get rid of that. Okay. Alrighty, let's dive back into the slides. Okay, so we've done isolation and we've done networking. The next one is persisting our data. Probably the most important topic for us SQL Server folks. How can we persist our data from one container to another? There are 3 options that we have for this. Bind mounts being the first one. Basically, mounting volumes from the host into your container. Now, I don't like this. I don't like doing this at all. Basically, because you're putting an external dependency on the container. So if you move container to a different host and it doesn't have the bind mount that it's looking for, it's going to fall over. Also, people use it to say, oh, I want to mount this really large database into my container. If you're mounting large databases in a container, probably shouldn't be using containers, but that's just my opinion. But so I'm not going to talk about bind mounts. I'm going to talk about data volume containers and named volumes. Two different options that we have. The first one being named volumes. And I'm not going to do anything in slides for this. I'm just going to go straight into the demos. So what are named volumes? Well, they are literally a volume with a name. We say Docker volume creating, imaginative as always. I'm going to call it SQL Server. There we go. And that's my volume. I can do volume ls, and there is my volume. Okay, great. What do I do with that? What I can do now is I can spin up a container and I can map it to a location within my container. So I'm going to map this volume to var opt SQL Server, a custom location within my container. I will point out, you don't really need to do this. You don't need to create your volume separately. If I ran this statement and SQL Server volume wasn't there, Docker would automatically create it for me. But I like to show you the steps going through it. That's why I did it that way, but you don't need to. So we're going to say Docker run, publish some ports, map my volume to var opt SQL Server, accept the end user license agreement, set an SA password, set a name, and the image that we're going to run from. So let's do that. Oh. There we go. That's better. All righty. Let's go and have a look at our container. There it is. States of 6 seconds. Now what I'm going to do is I'm going to create a database. Create a database on primary to the location we've just created, var opt SQL Server. So there we go. Hopefully that container's come up. Ooh, okay. We have an error. The reason we have this error is that SQL does not have access to this location. Remember, SQL runs as a custom user. It doesn't run as root. So we need to grant that user access to that location we've just created. If you have a look here, yep, there we go. Does not have access. So what we're going to do is we are going to change the owner of that location to the MS SQL user. So I'm saying Docker exec running as the root user, SQL container 1, change the owner of this location to MS SQL. Do that. And now if I try running the database, create the database, fingers crossed, we can create our database. We've granted SQL access to that location, so we can create our database for us. So we can confirm our database is there. Let's have a look at it. And there it is. Fantastic. Okay, and we can have a look. So what we're going to do now, there's our database. We're going to blow that container away. So what all this does is this lists out the container IDs on the host. I'm just saying grab that as a variable and then force delete all containers running. Not messing around here. Let's get rid of them. So just to prove I'm not cheating, container is gone. But I still have my named volume. So what I can do now is I can spin up another container, remapping that volume from an image. There we go. Okie dokie. Give that a couple of seconds to come up. Usually gives it about 10 seconds. Now, I don't need to go and change the owner to MS SQL now that I've remounted that container. We'll have a look now. But the permissions change has persisted. So I don't need to go back in and fix the permissions. So now I can use the for attach statement and recreate my database in my new container. Excellent. Okay. Let's confirm that database is there. Excellent stuff. We have persisted our database from one container where we created it, blew that container away, and now we've got our database back in another container by using a named volume. Okay, so let's blow that away. Right. So that's great, but it is all a little bit manual, really. Do we really want to be running that for attach statement every single time we spin up a new container? I want to get our databases back. Let's get our databases in there automatically. So let's create a couple of new name volumes called MS SQL System, MS SQL User. There we go. And we have our volumes. And now we're going to spin a container up. And what we're going to do is we're going to mount the MS SQL System name volume to var opt MSQL. Now this is the default directory for the system databases, specifically the master database. And then we're going to mount, as before, the MSQL user one to var opt SQL Server. And I'm going to set a couple of environment variables here for the default data and log locations to var opt SQL Server, which we're creating here. Let's go ahead and do that. Excellent. Okay, let's have a look. Aha. Okay. There we go. And then change the owner of the, still need to change the permissions, otherwise SQL won't have access. But now I can create a database. And I'm not having to specify where the files are because I set those two environment variables, the default data and log directories, to our custom location. So let's have a look at our database. Should be there. There it is. And I can check the files as well. So I run exec xp help file, and we can have a look. There we go. We have var opt SQL Server for the locations of our data file and our log file. And this is backed by our named volume. I have a look into I can view the database files that way as well. There we go. Cool. And we can see MSQL user has access. Alrighty, same as before then. Let's blow that container away. No mucking around. Let's confirm that it's gone. Yeah, definitely gone. But I still have my named volumes. So what I can do now is I can spin up another container, remounting the MSQL system and MSQL user named volumes. There we go. Okie dokie. And let's confirm that that container is running. Stay for 9 seconds. And now this time, let's see what's happened. Boom. Our database is there and has been brought back into SQL automatically. So by persisting, not just the user database location, but the master database location, our databases will automatically be brought into SQL when our new container spins up. So we don't have to muck around running things like create database for attach and all that. We can just have our databases there. Okay, we still need to sort out the permissions, but we only had to do that once. We had to do that initially. They will persist across, and then we can fix that, and we'll have a look at that in the next section. But that is using named volumes. So do a little bit of cleanup here. Now that's named volumes. Let's now have a look at a data volume container. Now, a data volume container is just a container with a load of volumes on it. And we can grab those volumes from the data volume container and mount them into another container. So let's have a look at creating a data volume container. Now, all I'm saying here is I'm saying Docker volume create. Don't have to run it. I'm just creating a container. I'm giving it a name of data store, and then I'm creating a load of volumes. So data, so system, user data, user log, backups, why not? And then I'm running a custom Ubuntu image here because what I want to do is grant access to these locations. We'll have a look at Docker files, which I used to build this in the next section. But for now, we're just running a custom Ubuntu image, and we're going to have a whole bunch of volumes for our data volume container. There we go. Okay, we've created our data volume container. We can have a look at that Ubuntu image if we want. All I've done here is let's do that actually. There we go. So from Ubuntu, based off the Ubuntu 18.4 image, creating a load of locations, make directory, creating the MSQL user, and then granting MSQL access to those locations. So I don't have to do it manually. I'm just creating all the permissions and setting them in my custom image. But we'll go into custom images in the next section. But for now, let's have a look at our data volume container. If we do this, we can see that it has a status of created. No ports map, nothing. It's not running. It's just sitting there with a status of created. And what that's done in the background is create me 4 named volumes. So now what I can do is I can spin up a SQL container with volumes mapped from my data volume container. And there it is. I just say -- volumes from data store. So I don't have to map each volume. I can just say, give me all the volumes from the data store. Handy if you want to map a large amount of volumes into your container. Okay. Let's run that. There we go. Confirm container is running. Yeah, there it is. Let's get rid of all that. There we go. Up to 7 seconds. Now we can create a database exactly as we did before. I set my environment variables here, data log backup, so my custom locations. So I can just say create database. We can have a look at that. Database should be there now. Test database 3. There it is. And we have our database files. There we go, in our data and log locations. Okay, so same as the last demo, let's just blow this away. Docker container RM. There we go. Getting rid of that, but we still have our data volume container. And that means we still have our name volumes. So now I can spin up yet another container, remapping volumes from our data store. Give that a few seconds to make sure it's come up. Give it a couple more seconds, usually 10 seconds, probably long enough. Okie dokie, and then let's confirm our database. Fingers crossed. Excellent stuff. There is our database. So we have two options, really. Kind of the same thing, because all that data volume containers are doing is creating name volumes in the background. But by using name volumes and persisting the location of the master database and our user databases, we can get our databases from one container, blow that away into another without having to, well, we still have to muck around with some permissions, but we'll have a look at that in a second. But we can persist from one container to another. All righty, let's blow all that away, bit of a tidy up, and let's jump back into the slides. So I mentioned the custom Ubuntu image there. What I want to talk about now is creating custom images. And what we do to create a custom image is we put a load of commands in a file that's on our host, and it's called a Docker file. The Docker file just has some commands in it that, when executed, build us a custom image. And what we can do some really cool things with this. We can set the permissions, so we don't have to go and manually set the MS SQL user to any custom locations that we create in our SQL for our user databases. And we can even add databases to SQL Server as well. We can get scripts to execute on startup and things like that. But let's have a look at a really simple Docker file. So we're starting off here. We're going to say from MCR, the Microsoft Container Registry.microsoft.com, MS SQL Server 29 CU5 Ubuntu 18.04. And this is just the image that we're going to base our new custom image off. So we're going to take the custom image, the Microsoft provided image, and we're going to customize it for our users, our needs. And there we go. Right. The next thing to do is we switch to the root user so we can perform some operations within our container. And then we're going to create a whole load of directories, like we did before with var op SQL Server, SQL Data, SQL Logs, SQL Backups. These are going to be our custom locations for our databases. Then we're changing the owner of the MS SQL user. Sorry, we're changing the owner of that location to the MS SQL user. Then we're switching back to the MS SQL user, and then we're starting up SQL Server. So SQL Server will come up, and it will already have access to all those custom locations. We don't need to manually go in and change the permissions on. So let's go ahead and let's have a look at building a custom image. Okie dokie. So I'm going to navigate to where my Docker file is, and we can have a look at it. It's exactly the same as the one in the slides. So MCR Microsoft.com server 2019 CU5, 2019 CU5 Ubuntu image. Switching to the root user, creating a whole load of directories, granting SQL access to those directories, switching to the SQL user, starting up SQL Server. Okay, let's build that custom image. So I'm going to say Docker, build me an image, -t, tag it with a name, custom image 1, and then dot. And all dot is saying is look in the current location for a file called Docker file. Okie dokie. So let's go ahead. And we can see Docker now stepping through each one of these commands, building us our custom image. There we go. Cool. We can see it doing each step. Switch there. Let's go through it. Let's have a look. So from our image, switches to the root user, creating our directories, granting access, switches to the MS SQL user, starting up SQL Server. And let's confirm we have our image there. And there it is. So if I do docker image ls, there is our custom image built 21 seconds ago. All right. So now I can create a whole bunch of name volumes. Why not? Firm my volumes. There we go. And now I can run my container from my custom image. So there we go. There's all my volumes that I'm specifying to those locations that we've already created and granted SQL access to in that image. Specifying a whole load of environment variables, data directory, log directory, SA password, give my container a name, and from my image. There we go. Okay. So let's get to check that container is running. There it is. Up to 5 seconds. Give it 5 more seconds. And let's check permissions on that folder. There we go. Cool. We can already see that SQL has access to that location. We don't need to muck around and do anything. So what I can do now is just go ahead and create a database. There we go. Let's confirm that database is there. Excellent. There's our database. Okay, cool. So have a look at the file locations. They should be on our custom locations. Let's have a look at it. Yep, var op SQL Server, SQL Data, and SQL Log. Cracking. Okay, so now, no mucking around. Let's get rid of that container. Confirm that it's gone. And now spin up exactly the same as the last demo. Spin up a new container, remapping our volumes from our custom image. There we go. It's up to state sort of 3 seconds. Give it a few more seconds just to make sure that it comes up. Fingers crossed. There's our database. So by using a custom image with custom locations that SQL already has access to, we don't need to manually go in and change the permissions. They're already set for us. So I can just create a database, and when I'm finished, I can blow my container away. And when I want to come back, I can come back in, create a new container from my custom image, and my database will be there, ready to go from when I left off when I blew my old way. So by using name volumes and custom images, we don't have to do anything else. We can just spin our containers up, and we are good to go. All righty. Okie dokie. Right, that's a bit of a tidy up. Let's go back to the home directory. Why not? Okay, jumping back into the slides. To tie everything that we've talked about today, so well, maybe not the container isolation stuff, but we'll talk about the networking, persisting data, and the custom images. We're going to tie it all together with Docker Compose. What exactly is Compose? Now, have a look at this container run statement. So we're saying Docker container should be Docker container run, but Docker run works. It's just deprecated. Docker container run -d run in the background. Map some ports. Specify a load of environment variables. Create a custom network. Sorry. Create this container on a custom network. Map our volumes. Give it a name, and then specify a container image. That's 15 lines of code. We really want to be typing that out every single time we want to run a container. Now, okay, you could drop it into a script file and just execute the script file, but there's got to be a better way. Thankfully, there is. This is Docker Compose. Now, when I first looked at Compose, I read the definition there, and it said Compose is a tool for defining and running multi-container Docker applications. And I kind of froze there and just like, oh, this is for just spinning up. Say I want to spin up a load of containers, like an app container, database container. I don't want that. I just want to run and spin up a SQL container. Compose isn't for me. But I went to DockerCon, and I went up to a load of the captains there. Didn't hassle them too much, but I did like, hi, my name's Andrew, and I have questions. But I was talking to them, and they were saying they use Compose for everything, even if they're just spinning up one container, because they can't be bothered typing all this out. They want to use Compose, configure everything in a YAML file, and then just deploy that YAML file. So let's go and have a look at what Compose is. So here we go. Right. Have a look at that. That's, yeah, I mean, I could highlight that and run that, but I'm not going to. Let's go to where my Compose files are, and then list all those files in the directory. Cool. Okay, so I've got a Docker Compose file here. got a Docker file, and I've got a SQL Server environment variable file. Let's have a look at that Docker file. That's exactly the same as the Docker file that we ran in the previous demo. So we're just creating our, basically from the Microsoft image, user root, creating our directories, changing the owner, switching to the MS SQL user, and then starting up SQL. And then here we have an environment, we have a SQL Server.env file. Now we have all of our environment variables. So we don't need to type those out either. Okay, I will admit this is very, very, very bad practice. Don't put your SA password in clear text in an environment variable file that you're going to put in source control. That's not a good idea. But I'm just putting it in there because I don't want to type it out in the demo. But don't do that. But you can actually specify multiple environment variable files, and you can have one in git ignore, I guess, and then just have the SA password in an environment variable file locally and not push it up to source control. But for the purposes of this demo, it's staying in there. Okay, and then finally, let's have a look at our Docker compose file. So here we say, oh, that's not great. Let's do this. There we go. Okay, we pick a version, and then we have to specify our services. This is where we configure our containers. So I'm going to call it SQL Server 1. Context dot, look in the same location as this Docker compose file for everything. Here's a Docker file. Here's some ports. Here's an environment variable file. And then we're specifying our volumes. So that means, actually, before we do all this, let's confirm what's all running on the host. Let's have a look at the networks, just the defaults. Volumes, no name volumes, and images. I've got a few ones here. I've got the CU5, my custom ones, Ubuntu, and my custom Ubuntu image. All good. Okie dokie. So let's spin up a container with Docker Compose. So I've navigated to where my compose file is, and all I say now is instead of that big long 15 lines of code, I just say Docker Compose up -d. Here we can see that it's creating my custom network, creating a load of volumes, and now it's building me my custom image. And that will finish in a second. And it's now spun up my container. And we can see that the image for the service SQL Server 1 was built because it did not already exist. And if I want to rebuild it, I can use Docker Compose build or Docker Compose up --build. But let's have a look at what that's built me. So let's have a look at the host. We have networks. I have a custom user-defined bridge network. I have a load of named volumes. I have a custom image that it built for me from my Docker file. And I have, of course, my container. And I can do it exactly the same as we did for all the other sessions, all the other demos even. We create a database. We can go and check all the files. There they are. They've already got permissions because they were set via our custom Docker file. And we can confirm our databases there. Excellent stuff. And now if I want to shut down everything, I can say Docker Compose -down. And that's what that's going to do is it's going to stop my container, but it will. There we go. And it's removed my network. But even though the network's gone and my container's gone, I still have my volumes. I still have my image. So if I wanted to, I could say Docker Compose, come bring it back up. All my volumes would reattach, and I'd still leave off where I'm from. So my databases would persist, same as we did before, but this time just using compose and not having to type out --env, accept the end user license agreement, MS SQL SA password, all the volume flags, the custom network, the name, the image. We can all do it in config files using Docker Compose. Okay. Just checking my time. How am I doing for time?
You've got 20 more minutes at least.
20 more minutes?
Yep.
Okay, cool. Right, we've gone through pretty much a lot. Let's have a look at some other stuff here. Now, what I'm going to do is jump back to custom images. Now, I said we could do some crazy, crazy stuff with custom images. So what I'm going to do is have a look at a gigantic image here. Now, there is some not best practice in here, but I just want to show you what you can do with custom images. So if we have a look here, we can do from Ubuntu 18.04. So just saying we're going to base our image from the Ubuntu 18.04 image. I'm going to drop a label in there called maintainer, DBA from the col.com. And I'm going to create the MS SQL user. So I'm going to user add, create the MS SQL user. Now, what I'm going to do is following the quick start install connect, I'm going to install some dependencies, add the GPG key, add a repository, and then I'm going to install SQL Server. So I'm building SQL Server from scratch. Well, it's from Ubuntu, but I'm going to install exactly as we would on Linux, but I'm going to install it in my Docker container. So what I can do now is I can install my SQL Server Tools. So I want to get things like SQL command in my container. So I'm adding another repo, updating the repos, and then I can install the MS SQL Tools. Then I can create some directories. So var up SQL Server, SQL Server data, SQL Server log, SQL Server backups. And I can copy some database files into those directories from my host. Now, people complain about this, but if you keep them small, it doesn't really matter. But you typically wouldn't want to copy database files into your container image. You'd mount it afterwards, but don't worry about that. This is just showing you what you can do. So what we're going to do is we're going to copy some files into those directories, test database log, and then we're going to copy a script in here called attachdb into this location. Then we're setting some permissions on those directories, and then we are changing the owner of those directories, exactly the same as before. We're going to make the script executable, set some environment variables, so I don't have to type them out each time I want to run a container from this custom image. Switch to the MS SQL user, and then I'm going to start SQL Server. But hold on a minute here. I'm running my attachdb script before I start SQL Server. What's going on there? Now, the reason for this is that containers need an active process running in them all the time, otherwise they shut down. If I had this the other way around, start up SQL Server and then run my attachdb script, once the attachdb script would become the main running process, and the container would shut down. So by switching it around, and if we have a look in this attachdb script, the first thing it does is sleep for 20 seconds. So attachdb script executes, waits for 20 seconds, which is just about enough time for SQL to start up, and then it attaches our database. So that little trick, it took me a while to work that one out. I think I read Bob Ward's book where he mentioned this, where if the last process is the attachdb script, Tay comes up, SQL comes up, attachdb script runs, that's the main running process. It goes, thank you very much, I'm all complete, shuts the container down. So by switching it around that way, we can get our database attached, and then SQL stays up and running. Okie dokie. Right, I can do another demo, but I just want to stop and pause and see, do we have any questions? I would run this, but it takes about 20 minutes to run because of this install here. So I'm not going to build that image yet, but all of this stuff is up on GitHub. Grab it, play around with it, see what you can do with it. You're more than welcome. But yes, any questions?
Yes, we have 3 questions so far. Can we mention the copy container file in Docker Compose or Docker file from container to localhost without using Docker CP command?
So can we copy files from the host into the container in Docker Compose?
Yeah, or Docker file from, yeah.
Yeah, use it in the Docker file. Do it exactly the same as here. Yep, there you go.
Okay,
Absolutely.
well, they asked that before you got to that step, so.
No worries.
And
remember,
then,
it's not watch the size
well,
of the.
they're saying they clarified container to localhost.
Oh yes, we'd have to use the Docker. Well, once the container's up and running, you'd have to use Docker CP. Yeah, you can't specify. Okay. You would be able to specify it in the image to copy it out. No.
Okay. Then the next question is, I'm using Postgres SQL image, and every time I run the Docker Compose up, the IP address changes. Any tip on how we can fix the container IP to static?
I think you can set an IP address for your containers. Off the top of my head. Oh, that's not the right button. Let's do Docker run. Not something I've looked at. Can we set an IP address? MAC address, no. There we go. There you go. IP. However, I would set them up on a custom bridge network and use container names instead of the IP address. That way you don't care about the IP address. You can always just use the container name.
Okay. Third question, how would this scenario be different, which you had just done? So the last thing that you had done. How would this scenario be different if we run it in Kubernetes, and how would the system, we're referring to SQL, respond or react if a container crashes and then we get restarted in both Kubernetes and with Docker Compose?
So Docker Compose is for running containers, whereas Kubernetes is for running, well, it's not this. I was going to say it's doing the same thing, but it's not. It's a way of running containers. I mean, you're just running custom images, so you could build your custom images and run them in Kubernetes. Absolutely, I would recommend not doing stuff like this in a custom image for Kubernetes. This is me showing you what you can do in a. This image will be gigantic. What I would do is you could build your image, build your custom images, push them onto your Kubernetes host, and then you can deploy, or push them to a custom registry, container registry, and then when you deploy into Kubernetes, Kubernetes can pull down your custom image, and they'll be up and running in your pods in Kubernetes.
All right, I believe that was all the questions.
Okay, how long have we got? Have I got time for another demo?
You've got 11 minutes.
11 minutes, really? Okay.
Yeah, you started at 10 after, you got an hour, so you got to 10 after.
Okie dokie. All righty. How did I get through all those demos? Okay, never mind. All righty. So I will preface this.
You did start 5 minutes early because we didn't have the sponsor here, so that might explain it.
Oh, I was confused. That's a lot of demos I got through there, but hey, no worries. We can do one more demo. So let's go back to container isolation, and let's talk about control groups, namespaces, and changing the root of the container. So if we know the constructs around that, the Linux constructs, can we run a container from scratch? And the answer is absolutely. Firstly, we're going to run a container. I know, but just wait. Run that container, and we'll confirm that it's running. Now, I'm just going to confirm that SQL is up and running. And if you do Docker logs, you'll get the output of, there we go, the SQL Server error log. Very handy for troubleshooting. There we go. Okie dokie. Now I'm going to stop that container, because what I wanted to do is once that is run from our image and all the layers underneath it are unpacked, I can export that container to a .tar file. Now, I'm not going to do that because it takes a long time, but I actually have it already. Oh, no. Sure. There it is, SQL Server .tar. And then what I can do is extract that into SQL Server. And why I'm doing that is because I'm going to run my container from that location. I'm going to change the root of my custom location, my custom container, to this location. This is going to be the root of our custom server. And I needed all the different bits and bobs from my SQL container to get SQL up and running. Everything's under there usually. Okay, and I've added a little file there so that we know I'm not cheating. That is actually the location that we're running from. So I've added the file. I can start up my SQL container. And let's list the root directory. See here, oh, that's not great. Yeah, okay. So we've got var user temp. This is the root, and that's what we've extracted here, ls SQL server. So we spun up a container, grabbed all of its files, shoved them onto the host, and now I'm going to blow that container away. We don't need it. I just wanted a copy of its file system. So we have our file systems. Now I'm going to navigate to some code. And let's have a look at some Go code. Now, I will preface this by saying I didn't write most of this. If anyone wants to go on the interwebs and check out Liz Rice's containers from scratch, highly recommend you do. This is basically her code. I'm going to post a link to the actual session there. Please go and watch it. If you're interested in this, she's going to explain it far better than I do. I've just made some tweaks to this to get SQL Server to running it. So this is Go. I'm not a Go programmer in any way, shape, or form. I just fumbled my way through it. So we're doing some stuff up here. But what we're in this function run, what we're doing here is we are creating our namespaces, new UTS namespace, new PID. Okay, and I actually forget what that one is, but I'm sure it's important. Sorry, UTS PID, cool. And then down here in child, we are setting the host name because we've got a UTS namespace. We're going to change it to container, imaginative as always. Here, we're going to change the root of this container to where we just extracted out all that SQL Server stuff. SQL stuff, Andrew, really, file system. We grabbed this file system, extracted it out to this location, and we're going to change the root of that container to this location. So we have change directory. And then coming down here, we are setting our control groups. So we've got our memory control group and our CPU control group. And we're going to limit our memory to 2 gig. And we're going to limit the number of CPUs this container can use to 2. So rid of that. And this is where this usually goes horribly, horribly wrong. Okay, so we have this, and I need to do Control Shift. Control D then. I can't do this. You know what? I'm just going to do this. Yes, yes. Okay, there we go. Right, so I've got my 2 windows. Now what I'm going to do is run that Go code. That work? No. It's going well so far, I feel. Oh, that's why I'm thinking. Thank you. There we go. Right. Okay, so we are in our container, and we can see that because this has changed. The prompt has changed. We're in root at container. And I can have a look at the root directory. Our root has changed to that location that we extracted. We can see there because it's got high DBA from the code. Alrighty, you can check the host name as well. Hey, host name has changed to container, whereas on the actual host it is Docker. So it's in a namespace. It's in the UTS namespace. Now I need to. SQL Server requires this file to do random sorting and things like that. I couldn't work this out. I couldn't get SQL Server up and running without creating that file, but Mark Wilkinson, a colleague of mine, actually worked it out. So I'm going to say thank you very much to Mark. But there's our file. So now what I can do is I can spin up SQL Server in my container. So I'll bin SQL Server. This is the location of the binary, and I'm just piping the output to null so it doesn't fill the screen full of a load of nonsense. And there we go. SQL's up and running. Let's check the processes. There it is in our container. Notice it can only see its own processes because it's in a process ID namespace that we created in the Go code. And if I look at the host, there's our process. We should be 2 of them starting up shortly. But look, we've got a root user. I'm running as root, process ID, and in SQL itself, we've got a different process ID because it's in the process ID namespace. So if I jump on the host again, we can have a look at our memory and CPU control groups, and we can see here and here SQL Server, and we can grab the memory limit. There it is, and we can show the CPU limit, 2000 as well. So that container, by running that Go code, we've created namespaces, we've changed the root, and we've set control groups to limit the resources of that container. All in just, let's have a look. How many lines of code is that? 82, kind of nifty. I mean, obviously, this is not. I don't go anywhere near production with this, or I wouldn't even say do it in development either. This is just literally just me mucking around with a load of Go code to show you how you can, if you know the concepts behind how containers run, you can spin up a container from scratch in 80 lines of code. There we go. Okay, so I'm pretty sure I'm going to be just out of time now. I've got 5 minutes left. I'm going to exit out of this. And I'm going to give you some resources. Actually, I won't do resources there. I will do resources here. So we have the GitHub repo for this session. DBA from the cold, Docker deep dive. Just the slides if you want to go and grab the slides. Summary of all the blog posts I've ever written about SQL Server and containers. And last year, I wrote something called the SQL Server and Containers Guide on GitHub. Now, this will take you from running your first container all the way to building custom images and using Docker Compose. If you want to check that out, you are more than welcome. And here is a link to Liz Roy's Containers from Scratch session. I highly recommend you go and check that out. She explains it so much better than I can, and it's really, really cool. And then at the bottom here is the installing SQL Server on Linux guide. So thank you very much. Tracy, do we have any more questions?
Just one more.
Okie dokie.
Sometimes there are no image volumes, etc., and we need to use Docker Prune image or volume. Why does this happen?
Docker Prune would remove, so Docker Prune volumes.
Yeah, they have volumes and images that sometimes it looks like they're not there, and they have to use that to maybe get them back, or I don't know.
Yeah. Oh, this basically Docker volume prune will remove all volumes that So that got rid of all my. I thought I got rid of those anything that's not attached. So if you do Docker volume prune, that will delete all volumes that aren't attached to a container. So be careful with it. I don't think of the image prune. Yeah. Let's not do that. So, prune is a way of tidying up your Docker host, basically. Should regularly go and have a look to see if you're running loads and loads and loads and loads and loads of containers on a host. You want to be regularly making sure that you're not leaving. They're called dangling images or unused volumes up there, just consuming space on your host. You want to do a little bit of maintenance, a bit of tidy up. Yeah, hope that answers the question.
All right, that was all the questions.
Fantastic. Okay, I'll just put a link on the slide there. I want to say, please do leave feedback for me. Let me know what you liked about the session. Let me know what you didn't like, and leave it. I think there'll be a link sent out somewhere. But everyone, thank you so much for watching this session. Hope it was useful, and I'll leave that until Tracy grabs the screen off.